Hey guys, welcome on the Artivoxer YouTube channel. Today we will learn how to create this scene inside Houdini. So let's take a look at the final render and let's dive into the tutorials. So here we are into Houdini. Let's start by creating a new geometry node and let's dive inside. So the first step is to create the first element of our scene, which is like a mountain environment. So let's start by adding a new grid. So with the grid, I will increase the size to 100 for each axis, and I will increase the rows and the column number to 1000. And here I will press H into the viewport to center the grid into the viewport here, and I will make it dark, so press D and put the background into dark. So here I will create mountain environment based on the grid on the mountain top, but you can also use 8 field. I think is a bit more efficient, but I want to keep things very simple, especially for the environment, because the main purpose of this tutorial is a cloth simulation, so I want to keep things simple for the environment. So here I will add my UVs into the grid, so let's add the UV and wrap. Now we have some UVs into the grid, and now let's add an attribute paint, so let's type attribute paint. And with this node, you can paint over your geometry and it will create a mask, and then we'll use the mask to create our mountains. So here I will go into the top view, so you can press space to go into the top view into the viewport here. And you can select this icon to paint into the geometry. So I will increase the size of the brush here, and you can paint as you want. Because the geometry is very high res, it can be a bit laggy, but here I will try to paint like this on my geometry, and I will make some random shape here. So maybe something like this, and I will make some shape into this geometry. So now we have our mask attribute, so we can use the attribute blur. So let's add attribute blur here, and we can visualize our mask. And into the attribute blur, I will replace the attribute from position to mask. And here I will deselect the pin border point, and I will put it into proximity. And here I will increase the blurring iteration to something like 100. And now we can see we have a bit more blurry mask. Now we can go back into the 3D view by pressing space 1, and here after the attribute blur I will add our first mountain node, so let's add a mountain sub node. And here it will create a mountain based on the whole geometry here, and I will also disable the preview of the mask here. So now we can see we have very low scale of mountain here, so let's change this parameter, so you have the element size and you can maybe increase to something like maybe 20 for this one, and you can increase the amplitude to something like 20 also. So now we have this type of effects, and the mountain is applied everywhere on the geometry, but we want to apply the mountain only where we have painted the mask. So you can use the blend here, so you can enable this parameter, and you can use an attribute to blend the mountain top with the mask we have painted just before. So here you can put it on positive. So now we have our mountain here, and you can change some parameters, especially with the noise pattern. So for the first one, I will go with this one. So we have this type of effect, and here you can play with different settings into the fractal also. You can play with the roughness and so on. So in my case, I will increase just a little bit the amplitude to maybe 25. And here you can play with the offset to change the position of the mountain. So I will go with something like this for now, so you can check the different parameter I used here if you want to use absolutely the same. So now let's add another mountain sub node. And with this second one, we can also blend it with the mask. So let's enable this parameter and let's use an attribute, and with the attribute is by default the mask. So here we can increase the element size maybe to something like 5. And here you can increase the amplitude to maybe like 2. And now you can put it into positive here. And now we have added a bit more detail into our geometry, but later we will use displacement and bump to create a bit more detail into our mountains. So if you want to create very high res mountain directly into the 3D here, you can use height field, and I think is a lot more efficient, but it's a bit more complex. So if you want to get a specific tutorial on height field and how to create icy mountain into Houdini, you can check out the link in the description. So of course you can play with the 2 parameter into the 2 mountain sub here to get a different result as mine. And after that, I will add my normal sub node. And then after that, I will add a match size. And here with the match size, I will put it into the minimum on the y-axis here. And I will put the target size at 10 on each axis. And here I can click on scale to fit to scale our mountain into a box of 10 by 10 by 10. So now we have this with a scale of 10 on each axis. So now we can add a null here to specify this is the end of our mountain. So we can rename it out mountain, for examples. And now we can start by creating our cloth simulations. So here for the cloth simulation, we can start by adding a tube, and the tube will be the stand for our flag. So let's add a tube here. So let's click on end caps and maybe increase the column to something like 50 columns, and you can decrease the radius scale to something like maybe 0.05, and you can maybe increase 8 to 2. So we can see we have this for now, and you can also increase the rows to 3, and now we have a new rows added into the center here. So now we can add our first group expressions. So let's add a group expression nodes. And for this group expression, we can create maybe a group with a face. So you can rename it face, and you can keep it into primitive. And here into the expression, you can type at p.z, which is over 0, for examples. And now we have this group. So we have selected all the faces over 0 into the z-axis. So now let's create another group expression. So let's add another one. So group expressions. And for this one, we can use an expression to select the top faces. So let's add another name. So for this one, we can rename it something like top. And for the expression, we can type for this one at p.y, which is over 0. And now we can see we have selected all the faces over 0 into the y-axis. So now let's add a group combine. And here into the group combine, we can combine the two previous groups. So let's add a group name. So we can rename it something like scatter, because we will use this group to scatter points just later. And here we can select the equal, which is the first group. In my case, I called it face. And you can select intersect with the second group, which is top. And now we can see we have this result. So we have selected all the faces here, and we have a group to scatter points later to create our flag. So now we can add a transform node and place our tube correctly on the mountain. So let's select the transform node here, and maybe we can merge the mountain on the tube for now to visualize where it's placed into the 3D space. So let's click on merge. So in my case, I think I will place it something like here into the mountain, but you can check the position you like to place your flag. So I will go into the top view, and here I will place my tube correctly with the transform node. So I will maybe move it something like here. Now I have my tube in that way, and you can also tweak the size if you want, because I think the tube is very, very big based on the mountain scale here. So I will go back into the tube and we'll make some adjustment to get a proper scale for the tube. So here I will change the radius scale to 0.0, maybe 2. And I will decrease the 8 to 1. And here I will place it correctly with the transform node one more time. So now we can remove our merge node because we don't need it anymore. So now let's add a scatter node to create some points on our tube. So with the scatter node here, we can select a group, and the group is the group we have created here with the group combine. And in my case, I'll call it scatter. So let's select that group here. And for the point number, in my case, I will go for something like 150, for examples. And here you can tweak the value if you want. And here, in my case, I will create an attribute wrangles. And I will create the normal direction to copy our geometry into those points. So let's add at n, and let's use the set function to set the direction on our normal. So let's set it at 0, 0, and maybe 1. And let's see the normal direction with this icon. And now we have the normal set in that direction here. Now let's add another attribute wrangles. And with this second attribute wrangles, we can maybe remove some points at the top of the tube here. So maybe we have 4 points for now we want to delete. So let's add an expression to do that. So in that case, it's fully procedural. So let's add an if function. So if at p.y is over a certain value. So let's create a parameter. Let's channel float something like 8, for example. And here let's use the remove point function, so remove point. And here the input is 0 and add ptnum for all the points. So now we have a parameter to remove some point based on the y position of the point. So now we can check the range of this parameter by clicking on this icon and click on edit parameter interface. And you can change the range by selecting this parameter, and maybe I will go from 0 to 5, for example, and click on apply and accept. And now we can change the value of this parameter. And in my case, I will go with this value. So we have that before, and now we have this. So we have just removed some point into the top of the tube. And now we can add an attribute randomize to randomize the scale of our geometry. And the geometry is our flag. So we want to add attribute randomize for the p-scale. So by default, the attribute randomize is set on the CD, and we want to replace this attribute with the p-scale attribute. And the p-scale is one dimension float value. And maybe for the minimum value, I will set it to maybe 0.5, and for the maximum, I will set it maybe to 2.2, for examples. So now let's create our geometry to copy into those points to create our flag. So to do that, let's create a line. So with the line, we can keep it by default for now, and you can change the direction. By default, it's on y-axis, so you can go into 1 on the z-axis. So now we have this line pointing into the z-axis. And now we can add a resample node to add a bit more points into our line and to create the curve view attribute. So with the resample, you can go with maximum segment length, or you can choose a specific maximum segments. So in my case, I think I will go for something like 50, for examples. And maybe I can increase the size length maybe to 3. Also, for example, now we can see we have this line for 3 units. And with the resample node, I will also create a curve view attribute, which is an attribute going from 0 to 1 into our line, and we'll use it later to create some group. And here, let's add a sweep node. And with the sweep node, I can create a geometry based on my line. So you can select the surface shape here, and you can select, for example, ribbons. And now we have created this geometry based on the line. So in my case, I will change the width parameter to something like 0.4, and I will change the scale here. So with the sweep node, you can change the scale based on a ramp. And I will add another point here and put the last points at 0. So now after the sweep, we can use the UV unwrap. So in that case, we have proper UVs into our geometry, and you can visualize the UVs by pressing space 5. So now we can see we have this geometry into the UV space. So now I will go back into the 3D view, and after my UVs, I will add a fuse node. Because for now, I have some overlapping points into the top point here, because we have reduced the size of the top of our geometry here to 0, and now we need to fuse all the points at this position. So let's add a fuse node to do that, and you can check the point number here. So after the fuse, we have this point number, and with the fuse node, we can maybe reduce just a little bit the point number, because we have fused some points at this position here. So now let's add a group expressions, and we can create a group for the based on our geometry here, for the base here, and we want to pin this group for the Vellum simulation just later. So here into the group expression, I can rename it something like pin points, for examples. And here I can change the group type from primitive to points, and I can type into the vex expression something like float at curve view, which is equal to 0, the based on our geometry, and now we have a group with all those points. So now let's add a remesh node, and in that case we can create some triangles based on this geometry, and with the remesh node here you can define a target size. So I will decrease it just a little bit to something like 0.1, something like this. And now we can use the copy to point to copy this geometry into the point created just before. So let's add the copy to points. And let's plug that one into the second input, and let's plug the geometry into the first input. And now let's see the result of our copy to points. So let's press H to center the geometry. So now we have this result, and you can merge the tube with the ribbon here. So the tube is here and the ribbon is here. So you can click on merge and visualize the results. And now you can see the ribbon are very, very huge. So you can add a transform node just after the remesh. So let's add a transform node here. And with the transform, you can reduce the scale to something like 0.1, for example. And you can also make a rotation into the z-axis to 90 degrees. So in that case, we have the ribbons pointing into that directions. And you can also play with the size of the sweep if you want to get more or less thick geometry. So in my case, I will maybe reduce a bit of the width value to 0.2, for example. And you can also maybe reduce just a little bit the size into the first part of the ribbon here. And now we have this type of geometry here. So now we can remove our merge node because we don't need it anymore. And now we can create our Vellum Cloth simulation. So let's add the Vellum Cloth constraints. And let's add the Vellum solver. So here we have the cloth constraints and the Vellum solver. But if you are looking the copy to point here, you can see you have some overlapping into the different geometry here. So to avoid that, we can play with the scale value. So you can go into the attribute randomize and you can add a keyframe with a global scale. So in that case, you can see you can increase or decrease the global scale of our geometry. So you can go into the first frame and put the global scale at a very low value to something like 0.1, for example. So now you can add a keyframe by pressing Alt and left click. And you can go at the frame 24, for example, and change the global scale to 1. And now you can see into the copy to point, we are increasing the scale into our geometry. So at the first frame, we don't have any overlapping issue. And of course, based on your scale geometry, you can maybe make some change into the global scale. Maybe you have to put a different value as mine. So now to update the scale of our Vellum simulation into the solver, we need to use the rest blend. So now we can add a null here and you can rename it something like rest, for example. And now we can dive into the Vellum solver. And here into the Vellum solver, we can use the rest blend node into our source. So this node will allow you to update the scale parameter into the Vellum solver. So you can select our SOP here. On our SOP node is a null created just before, so let's select it, and in my case I called it rest. And here you can update the frequency into each substep. So now the scale will be updated at each substep, and now into the force you can add some force into our cloud simulation. So for example, you can use a pop wind. And with the pop wind here, you can define a direction. So let's put the wind velocity into the z-axis to something like 2, for example. And you can increase the amplitude of the noise at 1 and decrease a bit the swirl size to 0.5. You can increase the turbulence to 4 and maybe you can decrease the roughness to 0.4. Of course, you can play with this value to get a different result as mine. And you can also use the pop drag after the pop wind here. And maybe with the pop drag, you can reduce a bit the hair resistance to something like 0.4, for example. And now we can see the result of our simulation. So I can go back into the SOP level. But before that, I need to select my pinpoint. So we have created a pinpoint here into our geometry. So we have the pinpoints into the based on our flag here. And I want to select this point to pin them into the based on our flag here. So to do that, you can go into the Vellum Cloth here constraint, and you can see you have the pinpoints. So in my case, I will select the group called pinpoints and I will click on match animations. So now I will select my Vellum solver and click on play to see the results of our simulation. And also I can put the tube into the collision object for the cloth, so in case we need it. So you can select the tube, which is here. So we have the tube into that node and you can plug it into the third input of the Vellum Cloth to create the collision object. So now I will click on play with the Vellum solver and see the result of our simulations. So now I've made my simulation into cache and you can see the preview of my simulation here. So for now I have these results. So I have my ribbon moving with the pop wind forces. So for now it's a pretty low resolution, but you can see into the Vellum solver I have increased the substep, so I put it into 4, and here into the collision path I put it into 30. Maybe you can increase just a little bit the substep a bit more, maybe to 6, but it will take a bit more time to calculate for the simulation. So in my case I keep it into 4, but if you want to get a bit more resolution into the simulation, you can increase the substep. So here into the forces I disable the gravity. And here I just increase the simulation cache memory just to get a better preview length into the timeline here. And here into the Vellum solver, of course, you can play with different value with the pop wind and the pop drag. And here into the Vellum rest blend, don't forget to select your constraint group. And the constraint group is a group called stretch. And here the group is the group from here, the stretch group from the Vellum Cloth. So here you can also play with the Vellum Cloth parameter. So in my case, I put the damping ratio to 0.05. And I put the stiffness into 4 multiplied by this parameter. And if you want to get a bit less deformation into the cloth, so for now you can see we have some wrinkles maybe everywhere here. So if you want to get a bit more less of wrinkles, you can increase this value. So if you put, for example, this one, you will get less wrinkles. But in my case, I like this parameter, and for the damping ratio, I think it's by default, and everything else is by default. So here is the preview of my simulation. So now we can add a Vellum post-process node. So maybe it's better to add the Vellum post-process before the cache. So in my case, I put the cache here just to show you the preview of my simulations. So let's add the Vellum post-process, and with the Vellum post-process you can add some subdivisions. So in my case I will put it in loop, and you can put the subdivision depth to maybe 2. So in that case, we have very high-res cloth simulations. And you can also add a bit of thickness into our cloth, so you can select this parameter. And in my case, I think the thickness default value will be pretty good. So let's see the result. It's a bit slow to calculate the thickness of each cloth. So now we can see we have a bit of thickness into each cloth. So I think it's pretty good for this specific simulation, but you can change the thickness scale if you want here. And after that, you can add some normals. And you can add an attribute delete to delete every attribute, for example, except our UVs, normals, and maybe you can keep the curve view attribute if you want to use it for the shading. And here you can add a null to specify this is the end of our simulation, so you can rename it something like render close. And now you can visualize our stand. So I have added a null here just after my stand, and you can visualize together with the merge node. So you can select the stand here and you can select the close, and you can see now we have the close and the stand like this. So this is a pretty basic Vellum simulation, so I hope you enjoyed this tutorial. Let me know in the comments. That's it for today, guys. Thanks for watching, and don't forget to subscribe to our channel and check artivoxar.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.